Hi, I'm Kseniia Shumelchyk, and today I'm joined by Slava Panasenko. We hope you're excited about the recent Android 12 launch. In this session, we will highlight the biggest compatibility changes in Android 12 and share tips on how to give your users a smooth transition into the latest release. While there are a ton of new APIs and capabilities to explore, we recommend to start by testing your current app and releasing a compatible update first. As people update their devices to Android 12, it's a basic but critical level of quality that ensures users have a good app experience. Along this talk, you will hear a few inspirational stories and recommendations from leading apps on how they made the most of Android 12 features and how you can do the same in your apps. First things first. Let's learn about key platform changes in this release. As you may know, there are two main types of compatibility changes: those that affect all apps running by default, and those that only affect apps based on the declared target SDK level. To make it easier, you will see the target API level badge in the corner of the slide for those changes that only affect apps that target the newest Android 12 SDK. Android 12 introduced the biggest visual refresh, powered by a new, personal material design. We have focused on simplifying and polishing existing experiences and helping you to build beautiful, secure, and performant apps tailored to users' needs. To bring these changes to life, we have centered our efforts on three main areas: user interface, performance, and privacy. In this session, we'll review Android 12 changes related to user interface and performance. To learn more about privacy updates, make sure to see our other ADS talk, Making Your App Private by Design. Let's continue with UI changes to give a consistent and intuitive app user experience. We have made changes to improve app responsiveness, so starting in Android 12, the system always applies the new default splash screen on cold and warm app starts. Such splash screen is constructed using your app's launcher icon and the window background of your theme. The new experience works out of the box for all apps running on Android 12. However, if your app implements a custom splash screen, you will need to migrate to the new SplashScreen API. We encourage using Jetpack SplashScreen library to enable backward compatibility and create a consistent look and feel across all Android versions. The new splash screens are fully customizable, so we recommend removing your existing splash screen activity altogether, even if it's used for routing. In this way, you will avoid the duplication of splash screens and reduce loading time. There are different techniques for doing that. You can learn more in our migration guide at developer site. Android 12 changes the appearance and behavior of fully custom notifications, making them visually consistent and easy to scan, with a discoverable, familiar notification expansion for the users. Previously, custom notifications were able to use the entire notification area and provide their own layouts and styles. For apps targeting Android 12, notifications with custom content views will no longer use the full notification area. Instead, the system applies a standard template. This template ensures that custom notifications have the same decoration as other notifications in all states, such as icon, app name, and expansion and collapse state affordances. The change affects apps that define custom subclasses of notification style or which use notification builder methods to set custom content view. If your app is using fully custom notifications, make sure to test how they work with the new template. Android 12 also consolidates existing behavior to make it easier for users to perform gesture navigation commands while in immersive mode. The existing behaviors for immersive experiences are now deprecated. They're replaced with the new default behavior that allows users to perform gesture navigation commands only with one swipe, instead of two required on Android 11. If you're developing a full-screen gaming experience, you can still protect users from accidental gestures in immersive mode by using a dedicated flag.
Let's now dive through the changes that affect actual and perceived app performance for users. Foreground services are a great tool that allows Android system to ensure resources for completing long-running user-initiated tasks at a high priority. However, they're often misused. We found that almost half of the foreground services are launched from the background, which leads to many issues, including those related to battery drain and user confusion when a user sees an unexpected foreground service notification. Hence, starting from Android 12, we will disallow starting foreground services from background and restrict launching foreground services to visible activities and user actions. There are less common use cases, such as handling certain broadcast receivers or companion device manager apps. For the full list of exemptions for foreground service launch restrictions, visit our documentation on our developer site. Earlier this year, we introduced Expedited jobs as part of Work Manager Jetpack library. These are low-latency jobs that can be invoked from either foreground or background to be executed right away. They can run during low-power modes, and we encourage developers to use them instead of launching foreground services when possible. In most cases, apps should use inexact alarms, which have the advantage of being battery-friendly. For special cases, like alarm clocks and timers, you can use exact alarms. In Android 12, we are adding a new manifest permission to give users visibility and control over the apps that have this permission. We have added a new API to let you check the permission status of your app. For users, app startup is important so they can keep focused on their task. Therefore, in the Android 12, we are introducing new features and some changes in behavior for app startup aimed at making users productive and happy. We have already covered new splash screen animations. Now we will cover a couple more changes, starting with notification trampolines. Some apps use intermediate components, such as broadcast receivers or services, when handling user taps on notifications. Those are known as notification trampolines, and they often lead to delays and interrupted user flow. Apps targeting Android 12 won't be able to start activities from those trampolines. This new restriction helps reduce latency for apps started from a notification. We encourage you to move away from notification trampolines and start target activity directly from a notification. For example, the Google Photos app now launches 34% faster after moving away from notification trampolines. If your app uses notification trampolines, use the following ADB command to see which component was launched when the user interacted with a notification. Android supports the notion of app links that lets HTTP URLs be directly linked to an installed app by passing the disambiguation dialog entirely. They improve user experience by removing friction from user journeys. App links are different from deep links in that app links can only handle HTTP schema, while deep links can be any schema. Probably the most important app links behavior change is that unlike previous versions, Android 12 will always open the default browser for non-verified links. Android 12 also introduces link-by-link verification, so if you have any server-side integration or configuration issues, errors will be limited to links that don't pass verification. New Domain Verification Manager APIs let you check for domain verification states and, if needed, take the user to settings for them to approve domains for your app. Learn more on our developer site.
Now that we have learned about new features and changes in Android 12, let's look at testing and tooling to make your apps compatible. In Android 11, we have introduced compatibility framework tools to make it easier to test and debug your app against changes. With these tools, you can turn on and off breaking changes individually and evaluate how it's impacting your app. In this way, you can isolate and test against only one behavior change at a time, or easily enable changes behind Target SDK. You can check which behavior changes are currently enabled using the developer options, Logcat or ADB commands. For each behavior change, the first time when your app calls the affected API, the system outputs a Logcat message like this. You can identify all compatibility changes known to the system and their current overrides using the following ADB command. Each change in the list has a name, change ID for reference, and whether it's enabled or disabled. ADB command can be also used to toggle changes on or off for a certain package. No need to change target SDK version or compile your app for the basic testing. Android platform will automatically adjust its internal logic. Because changes are individually toggleable, you can isolate, test, and debug behavior change one by one, or disable a single change that's causing issues. Changes can be only toggled for debuggable apps. So if you don't see your app in Compatibility framework, make sure you set your app debuggable in your manifest. Keep in mind that on release-signed Android builds, the changes that affect all apps can be overridden. Android 12 adds new ADB commands to test and validate app links for your applications. You can use these commands to verify your links manually on a device or add them to your continuous integration toolchain. Make sure to try Android Studio Arctic Fox for your development and testing. We have added link checks to help you catch where your code might be affected by Android 12 changes, such as custom declarations of splash screens, course location permission for fine location usage, media formats, and many more. To get started, set up the Android 12 SDK. Now we want to showcase developers that have already adapted to Android 12 changes so their users can take advantage of new experience.
Vsync HealthMate app allows users to connect and sync Vsync devices over Bluetooth. Android 12 introduces new permission that decouples Bluetooth scanning from location permission. Location permissions and their relation to Bluetooth are difficult to explain to end users on the privacy level. For a few years, Vsync's team had to invest in customer service topics and tutorials to educate users about why the app needs location permissions to scan for Bluetooth. Even with a good explanation, they had negative reviews for asking for location permission to scan for companion devices. Nearby devices permission is way more effective as it asks permission only for scanning and connecting. A couple of tips from Vsync's engineers. First, abstract logic for checking and requesting new permission. That helps to control entry points and minimize testing effort. Second, unit test all the permissions checks on all supported Android versions. Third, use actual Android devices and test different upgrade scenarios to ensure the app behaves correctly. To reduce user friction, nearby device permission will be granted automatically when a user upgrades to Android 12, but only if the app already had a location permission granted on the previous Android version. To use new nearby device permission, you must declare Bluetooth scan permission in your manifest file. This is a runtime permission, so in addition to declaring it in the manifest, your app must check and request this permission at runtime before initiating device discovery. By declaring uses permission flags attribute as never for location, the developer indicates they don't plan on using the scan results to derive user location. If you only need to connect to devices, you can declare Bluetooth Connect permission. Let's look at one more Android 12 change we haven't previously covered, Stretch Overscroll Effect. Most of the apps will have a new overscroll stretch effect working out of the box on Android 12. Some Android 12 beta users noticed a strange effect when scrolling through their messages in the Signal app. In Signal's case, the app supports custom backgrounds. The app used a masking algorithm that basically punched through the screen. Whenever the contents are laid out or scrolled, the Signal app would build a list of the projections of message bubbles on the screen. Then the app would use those projections to create a mask to apply to a given gradient or solid colors. The engineering team was quick to come up with a solution using Recycler View item decoration. Fixing the overscroll issue early let Signal app deliver the experience people expect on the newer devices without compromising performance. Recommendations from Signal team. Pay attention to blending modes and how they work with additional layers. Android 12 Overscroll uses an additional layer to render the stretching effect and that can generate different results with various blending algorithms. Another important point is to ensure that the background is rendered by Recycler View. Do a thorough QA and address beta user feedback for Android 12 compatibility ahead of the release. Signal app is a great example of delivering delightful user experience. Luckily, the Signal private messenger for Android is open source, and you can check out their fix on GitHub. You'll find a link to changelist below in the description to this video. In this talk, we tried our best to cover the most important changes Android 12 brings to developers and ultimately our users. There are more changes, and we encourage you to check them at developer.android.com. Most importantly, we'd like to remind you to test your apps and confirm compatibility with Android 12. Many developers already did. It's now time for you to get ready for these changes and deliver great user experiences. We're looking forward to seeing your apps on Android 12.